This is approximating square roots. We're going to be talking about the set of real numbers, which includes all rational and irrational numbers. Rational numbers are numbers that can be written as a ratio of two integers. Basically, they can be written as a division problem in fraction form with a numerator and a denominator. Things that are included in the real number rational category include our natural numbers. Natural numbers are counting numbers like 1, 2, 3, 4, 5, 6, and so on. The whole number category is all of those natural numbers and 0. So now 0 is included. 0, 1, 2, 3, 4. Integers are all of the numbers included in the whole number category and their opposites. So now we have 0 and 1 and -1, 2 and -2, 3 and -3, and so on. And then other things in the rational number category are things like fractions like 1/2 or -2/3, or decimals like 2.25, this is a terminating decimal, or 0.3 a repeating decimal. Those are all rational numbers. Irrational numbers cannot be written as a ratio of two integers. Examples of irrationals are square roots that are not perfect squares, cube roots that are not perfect cubes, or any type of decimal that does not terminate, which means it does not have an endpoint, and it does not repeat. There is no repeating pattern to it. So things like pi, or the cube root of 7, or the negative square root of 3, or the square root of 2 are just some examples of irrational numbers. So let's talk about classifying some real numbers. So if I was asked what groups the square root of 12 fits in, I would say it's irrational. When something's irrational, it's not going to fit into any other category, and I know that it's irrational because 12 is not a perfect square. 0.25 repeating, so 0.25, 25, 25, 25, going on forever, is rational. Any repeating decimal is a rational number and can be written as a ratio of two integers. The negative square root of 9 is not only rational, but it can also be in the integer category because the negative square root of 9 is actually equal to -3, which is an integer and a rational number. 72/4. This one is actually a rational number, an integer, a whole number, and a natural number, because 72/4 is actually just equal to 18 if I divide or simplify. So it fits in all these categories. 18 is a counting number, a whole number, an integer, rational. So I'd want to list all of those. And lastly, pi. Pi is an irrational number because it actually represents a decimal that does not end and does not have a repeating pattern. Let's try approximating some square roots. So we're asked here to estimate the square root of 71 to the nearest integer and the nearest tenth. So first I'm going to try to find the nearest integer. So I know that if I square 7 times 7, it's 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. So I'm looking for the nearest integer. The closest thing to 71 here is going to be 64. So once I know that it's somewhere in the 8 category, a little bit greater than 8, I'm going to try testing some things that start with an 8, like 8.3, 8.4, 8.5, 8.6. So 8.3 squared is 68.89. 8.4 squared is 70.56. 8.5 squared is 72.25. 8.6 squared is 73.96. And so the closest one here is 8.4. So if I were to estimate the square root of 71 to the nearest integer, I would say 8. And if I was estimating to the nearest tenth, I would say about 8.4. Let's compare two real numbers here. They want to know which is greater, the square root of 5 or 2 2/3. Well, first of all, let's try to find the square root of 5 to the nearest integer. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So it's a little bit bigger than 2. It's closest to 2, but it's going to be a little bit more. So we want to graph them on a number line. So I know that 2 2/3 is going to be pretty close to 3 right here. And then I have to figure out where the square root of 5 is going to be. Well, it's pretty close to 2, just a little bit more, so I don't know exactly where it is, but I'm going to estimate it's a little bit more than 2, which means if I'm trying to figure out which is greater here, it's going to be my 2 2/3. So this one says the radius of a circle with an area A is approximately the square root of A divided by 3. The area of a circular mouse pad is 51 inches squared. Estimate its radius to the nearest inch. So 51 is going to go in for our area. 51 divided by 3 gives us 17. Now 17 is not a perfect square, but the closest perfect square to 17 is square root 16. So I'm going to say this is going to be about approximately 4 inches for our radius. Let's look at one real-life example here. The distance in nautical miles you can see with a periscope is 1.17 times the square root of h, where h is the height of the periscope above the water. They want to know, can you see twice as far with a periscope 6 feet above the water than with a periscope 3 feet above the water? And explain. So first we have to actually plug in these numbers and get some numbers to work with. So we're going to look at the periscope 3 feet above the water compared to 6 feet above the water. So the first thing I want to do here is just kind of approximate these, and I can do the square root of 3 times 1.17 in my calculator. I get about 2 here. The square root of 6 times 1.17, I get about 2.9. So to get from 2 to 2.9, I'm multiplying by about 1.45, definitely not twice as far. So no, you can't see twice as far. You only see 1.45 times as far with the periscope 6 feet above the water.